Welcome back, students. In this video we're going to cover Module 8, Topic 2, Similar Polygons. This is page 5 of the Module 8 packet. Let's see, we got the warm-up. Just go ahead and get started. Are the triangles congruent? Justify your answer. So let's draw some congruent marks in some different colors. To me, that's the easiest way to... Makes it easy to see, makes it easy to come up with your answer. So, I'm going to make the singles pink. I'll do that all the way across here. Alright, let's go green for the twos. Pair of threes here, so they'll be blue. We do have our box here. I like to make it red. It just makes it a little more visible. Okay. Alright, so are the triangles congruent? Justify your answer. Hopefully you've been kind of looking at this and worked on it. So, for number one, so these sides are congruent. So these sides are these sides. So for number one, these guys are congruent, and we have a side, and a side. Okay. So yeah, side. All right, number two. So we have these two triangles. Are they congruent? Well, we have the marks, but obviously this and this are not the same size, XYZ and RPQ. What this means is these are two equilateral triangles, but they're not congruent. And then number three, so we have two right triangles because we have the box. Remember, we worded a little different for right triangles. We have the hypotenuse and the legs. Hypotenuse is always across from the 90-degree angle. So here we have a leg and a leg. So yes, and it's leg for number three. I do want to put this, so two equilateral triangles. All right, moving down. Again, still on page 5. Similar polygons. A dilation is a type of similarity transformation. So a similarity transformation is a transformation composed of a dilation and a rigid transformation. Bear with me a minute. So two similar figures are similar polygons if one can be obtained from the other by dilation or a dilation with one or more rigid transformations. So let's look below here. I'm gonna apply some color so we can do this a little bit. So, all right. So ABC can be mapped onto DEF with two rigid transformations and a dilation with a scale factor of K. Of course, that's what we measure, or we call the scale factor is K. So ABC is similar, and that's what this symbol. So it's like the congruent. It just doesn't have equals, just the little tilde on top of the equals. I know mine doesn't look right, but mine looks more like a small lightning or something. But anyway, so what it's saying. So let's do this. This kind of helps me, and maybe it'll help you guys. Let's get the pencil. So, probably not exactly in the middle, but maybe this will help. So, I'm going to keep it the same color because we need to understand this is the same triangle we have just reflected. So, it says, so first it reflects over this line. I just put it as close as I could to the middle. Then it translates, so it scoots. I'm going to make this yellow. scoots down here, translation. So if it was on the coordinate plane, it would go right so many and up so many. Just do that. Just go right, then up. Kind of illustrate that. So we end up right here. So two transformations, a reflection and then a translation. Excuse me, two transformations. Man, I get messed up on the word. Okay. All right, so scale factor of K. So as we dilate, as we learned in the last lesson, our pink triangle will turn in eventually into the big green one. I'm just not going to color it all the way in. I want you guys to see. So we flipped over because we reflected. And then we scooted over when we translated, and then we dilated and made it bigger. Let's see if we can see how there. Kind of gets lost in the copy there. Okay, so hopefully we're tracking that. Let's move. Well, yeah, let's actually talk here before I scooch down. So theorem 8.1, similar polygons. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So angles are congruent, corresponding side lengths are proportional. Okay. Let's see. So yeah, the symbols, as I said, the similarity would be ABCD is similar to WXYZ. So, all right, let's scooch down. So you guys, we've talked about reflexive, symmetric, and transitive a couple of different times. So we're going to talk about them again. It's the same principle, just the only thing that changes is the circumstances. So here we're talking about similar polygons. So like for 8.2, these are your properties of similarity. So first we have reflexive. As we've talked about, just like when you look in the mirror and you see your reflection, the reflexive property has to do when we're talking about a point, a line, segment, an angle, or a shape. It's the same thing. So ABC, triangle ABC is similar to triangle ABC. When you look in the mirror, you see yourself. Okay, so symmetric. So ABC is similar to DEF, then DEF is similar to ABC. You know, if you and if I have the same amount of money as you have the same amount of money as I have. I know it's a little different, but I'm hoping this helps. So in the transitive property, we're talking about three different shapes. So if triangle ABC is congruent to is similar to DEF, and if triangle DEF is similar to XYZ, then that means that ABC and XYZ also have to be similar. And I'll hopefully illustrate that better in class, but it's the same thing we've talked about. All right, so let's flip over, go to page 6. All right, page 6, top of the page, number 1 on the left. So, it says ABCD is similar to PQRS. List all pairs of congruent angles and write a proportion that relates to the corresponding sides. So let's see what we do here. So for here, the way they give us, so the letters they give us are the letters that tells us everything if you just follow it. So AB are your first two letters. PQ are your first two letters. AB is the first side here. PQ is the first side here. And I'm making them the same color. I can't make the letters the same because we're going to be kind of running over each other. So the next two letters, BC. Let me change pencils before I mess up. So BC, QR. BC, QR. Do a little road map, okay? Next up, CD. CD. And see, notice we're just following the shape all the way around, you know. CD, Q, no, we did QR. RS. RS. And then, lastly, let's see which color have I not used. I have, alright, and then, so we went CD, now DA. DA. SP. SP. See? We just followed our shape all the way around. So now we can see. It's probably not quite as visible as I'd like it. I may choose different colors next time. But so we're just going to write these in. So AB. AB is green. What else is green? PQ. BC is brown. So we're going to go, hold on, how do we, yeah, we went PQ, so BC was brown, QR is brown. CD is blue, RS is blue. And then DA is pink, SP is pink. So those are our sides. Let's see. The angles, so you just put the colors together. I'm going to try to do this a little different. So for A has pink on the left and green on the right. I'm giving it 1. P has pink on the left, green on the right. Another easy way though, A goes with P. And we can also do it that. I'll show you both ways. I mean, let's see if I have any other colors. Let's just use the red pen. We can do that. So B's next, Q's next. B, Q. Notice green, brown, green, brown. So we don't have to, you know, get complicated with it. And I'll just do 3. We don't have to do the 4th. So C, C's next, R's next. C, R. These are the same color, same number, because they're corresponding angles, corresponding sides are the same color. So this is C and R, C and R, and then obviously D and S. D and S go together. Blue, pink, blue, pink. So easy road map, just got to be patient and follow it. Number 2, NPQR is congruent, is similar. I got to get out of that habit to UVST. List all pairs of congruent angles. Let's see, and write a proportion that relates to the corresponding sides. So we're going to do the same thing again. Instead, this time we'll actually write the angles instead of doing those, or we may do both. So NP. Try to make the lines a little thicker so we can just maybe see the color a little better. NP, UV. UV. And see, they don't, I went right here because it was the same spot. Don't do that. Look at what you're doing there. So since we started here at N and we started here at U, I'm just going to write that angle N similar to angle U. Those are the corresponding angles. Well, congruent actually. Forgot the rule I gave you guys. So similar, the sides are going to be in proportion, the angles are congruent. Almost missed a good opportunity there. Okay. So next 2 letters, PQ. PQ. VS. VS. And then we got Q and V. Q, V, next 2 letters, QR, QR, ST, so we started with, that was Q, it was N. Oh, I skipped P. Oh, Lord. So you see P right here. And then over here with the green to the left, the pink to the right is V. What did I do? Oh, I did Q and, alright, yeah, so we'll just say P and V, and then down here we'll change this to Q. Q had it's got blue to the right, I'm sorry, blue to the left, pink to the right, and then S would be over here. So, also notice Q is the third letter, S is the third letter, P, V, N, U. But I would rather make mistakes like that and be able to show you guys what happened. So, lastly, RN, TU, TU. And then that leaves angle T and angle R, T, R. All right, now, side NP is green, UV, and again, we can do this, NP, UV, PQ, VS, RN, I'm sorry, well, I skipped one. It says RQ, I would have said QR, but, so RQ, TS, instead of STC. And then RN should be TU. Okay, scooching down. All right, I'm gonna color these congruent marks. Go ahead and color them in before we start. Make the singles pink and the doubles blue. Okay, you guys can see that. All right, determine whether triangle NPQ is similar to RST. So they show us here with the marks, and if we were to mark these on our own, you start, you know, N, R, R. So, are these two similar? We gotta check our proportions. So, NQ and RS. So let's say NQ should be proportional to RS. So, NQ 12.5, RS is 10. Let's see. So 2.5 will go into 10 4 times, and 2.5 will go into 12.5 5 times. So our proportion's 5 4. So let's see if the others match up. So next side, so let's go this way. So QP, which was the blue blank, would be ST, blue blank, which is also QP, ST. QP, 11.5, ST, oops, 9.2. Divide those out, that is also 5/4. And let's see, lastly, we've got PN over TR. PN is 15, TR is 12. Go down here with this. 3 goes into 12 4 times. It goes into 15 5 times. So you see we are in proportion, so it is yes. The reason is, let's see, side, side, side. Even similar because all 3 sides are in proportion. Let's see. Last year I included the third angles theorem in it because these two are congruent. The third has to be, and that's because if these 3 sides are in proportion to these 3 sides, they're similar, and then all 3 angles will be congruent. So this extra stuff is really just helping us also see what we were, the sides, you know, the corresponding sides, excuse me. Okay, all right. So we have two rectangles. Well, it says determine whether quadrilateral ABCD is similar to quadrilateral EFGH. If so, find the scale factor. So EFGH, ABCD. So BC and FG should be in proportion if these guys are similar. So that would be 8, 12. 4 goes into 8 4 times, into 12. Sorry, 4 goes into 8 2 times. God, into 12 3 times. Lord. So 2/3. All right, so the other side, CD, goes with GH. So we have 10 over 14. That's going to be 5. If 2 goes into 10 5 times, 2 goes into 14 7 times. So we are not similar because they're not in proportion. I didn't realize I was sideways there. All right, let's scooch down the page. Looking at number 5 and 6. Figures are similar. What is the measure of the missing side? So let me just, let's see. So we got X here. I'm gonna just write these in. Well, let's see. Can you see them okay? Yeah, X wasn't great. Okay. So we're gonna, let's see. We'll take, to find out the missing measure, so everything should be in proportion. This to this, this to this. Anyway, so over here we have, it's gonna be JK over PQ, which is 4 over X. And then the other one we're gonna pick another that's in proportion. I like regular numbers. We'll just go LM or ML. No, it'll be LM because we're going this way. LM RS, which is 5 over 9. So now we're going to cross multiply these guys. So 4x 5 over 9. We're going to do this, back it up old school a little bit, maybe in a while. So cross multiplying. We're going to cross these guys, multiply this way, and multiply this way. So let's go back red. So 5 times x is 5x. 4 times 9 is 36. Divide both sides by 5. And x is going to equal 7.2. So this missing angle, the missing measurement, 7.2. Easy peasy. All right, same thing for number 6. So we have a question mark here. I'm just going to call it x. This is 5 and not easy to read. You see the 7, 4. Okay. So again, let's get our corresponding sides. So AC and PR. So AC over PR. And then we'll just say AB over PQ. So AC is X, PR is 5, AB is 12, PQ is 4. So now we're going to cross multiply. Again, just to help us out, these two times these two. 4 times X, 4X, 5 times 12, 60. Divide both sides by 4. X is going to equal 15. So our missing measurement there is 15. All right, moving on. Video ended up a little long here. All right, page 7. Whew. Scoot this up. Excuse me. All right. Page 7. So we got a little bit here. It kind of cut off the way the page goes. So it's 7 and 8, but there's really just a little over a full page. So top of page 7, number 7 on the left in the diagram, WXYZ is similar to PQRS. Find the value of Y. So I'll do something a little different this time. So our first letter is W. I'm going to make it green and P. All right, so first letter W and P, and then the next letter X, Q. I should have done this above it. Y is next, and R, and I'm just going to have to write it to the side. What did I? Green, blue, pink. What's left? And yeah, well, you won't be able to see yellow. I'll just do in the red. So Z, S. I'm not even on the screen. Dang it. All right, so then I'm just going to color that way. Well, so really all you need here is the corresponding parts, even though this thing's flipped upside down. Notice that R is pink, S is red. I'm just going to take the pink out. So RS, pink and red, I'm going to make the line pink. YZ, pink and red. Make it pink. So our corresponding sides, so all we got to do to find X is put these two equal to one another. Or, well, cross multiply to solve for X. I'm sorry, Y. Good Lord. Actually, no. It'll be, I got to find the other side. Lord, I'm getting ahead of myself. So let's see. SP is red green. ZW is red green. I'm just going to grab the green because I can. So what I said WZ and SP. So let's write this out. So our pinks are together, so it's YZ over RS, which is YZ is 5Y minus 2 over RS is 6. And then the other one is SP over ZW. So SP is 12, ZW is 16. Just a second. First we're going to cross multiply. Oh, well, let me set it up here. Hold on. So 5y minus 2 over 6, 12 over 16. So multiply here, cross multiply here. All right. Numbers may get a little big here. So this is 16 times 5y minus 2. So it's going to be, we're going to distribute 16 times 5y. So 16 times 5 is... Hang on 1 second. Sorry, guys. I think somebody's at the door. Makes, because those are corresponding angles. And so instead of looking up here and having to do what I've been doing this video to kind of get you guys in the habit, you can just look. Excuse me. So J and Q are corresponding. JM, so 1 to 2, QT. And if you look up here, JM, so JLM, yeah, JM would be, or MJ is the way we would have said it, the way I'm doing the letters, but it doesn't matter. All right, so these two are similar. Find the value of x, round to the nearest tenth if necessary. So our corresponding sides, JM and QT. And then the other is ML and TS. Okay, so JM is 4, QT is 2, oops, ML is 6x minus 3, and TS is 3. Okay, so bring it over here, cross multiply. So we have 4 and 2, 6x minus 3 and 3. Didn't exactly get that 3 in there very well, but you guys get the point. Alright, so 2 times 6x is 12x. 2 times negative 3 is negative 6. And then the other side, 4 times 3 is 12. So we got 12x minus 6 equals 12. Add my 6 to both sides to get my 12x by itself. 6 plus 12 is 18. Divide both sides by 12. You get, so x is going to be 1.5. And if you look, so we have 4, we had 4 to 2. So if the other side was 3, this would be half of 3. So it would be 1.5. Okay. Down here before we make the video too long. Number 9. So is is triangle PQR similar to triangle XYZ? If so, what composition of transformations maps triangle PQR onto triangle XYZ? So this is one of your level 4, level 5 questions, because it's, it's going to take a little bit of work here. Excuse me. So the first thing we're going to do is we're going to get our coordinates. -1, -2, -3, 1. So that's -3, -4 and a half. So -4 and 0.5. And here we have -3, 1, 2, 3. So -3, +3. And then we need to know where we end up. So this is 0, 1, 2, 3, 4. Z is at the origin, or 0, 0. And then Y is over here at 2, -1. First thing I want to do is color in this guy. So, excuse me. Keeping with the theme, we'll start with green. Okay. So, common vertices are R and Z. R and Z, because they're in the middle of the triangle. So let's see. If you count, so what I believe we're going to do by looking at this and, teaching before, it looks like we're going to have to scoot this guy over to line him up next to here. All right, just imagine. Then he'll reflect and he'll be over here, and then we blow him up to that, because you see the triangle, how it's shaped this way, and this one's the opposite way, but it's bigger. So first thing I want to do is get him down here. Let me write this in pencil. So we're gonna let's see. Wait a minute. on, let me think about this a minute. First thing, yeah. So we're going to translate. And it's going to be, remember, our x, or our direction. It's magnitude and direction, and I can't remember which is which, but A is left to right, B is up and down. So first we're going to go right 1, 2, 3. And then we go down 1. Now, I'm going to show you in the math, then I'll graph it, how it's going to be right here. So if we translate 3, 1, that means our x comma y will be x plus 3, y plus 1. Okay? So let me write, so P and X, R and Z, Q and Y, but let's see, how did we do this? We'll just start with P over here, because I don't know how much room I'm going to need. P was -3, +3. Q is -4 and 0.5. And R was -3, +1. Alright, so if we're going to do as I said, x plus 3, so -3, let's just do it like this. -3, that's x, plus 3, and then the y is y plus 1. So that takes us to -3 and +3 are 0. So we want it to be on that line, so that's looking good. 3 plus 1 is 4. Let's do this. X is -4 plus +3. Y is 0.5 plus 1. Easy enough. -4 and +3 make -1. And then 1.5 make 1.5. -3 plus 3, our y is 1 plus 1. -3 plus 3 is 0. Again, we were trying to get two of these sides to that line. 1 plus 1 is 2. So let's see where we're at. What color? All right, let's go blue. All right, so 0, 4. 0, 1, 2, 3, 4. -1, then +1.5, and then 0 and 2. Let's see. Oops. Man, I keep getting. All right. This is straight down the line. So now we've. Wait a minute. Oh, we don't add. Oh, we don't add 1. We subtract it. We went down. It's okay. So let's just change. Actually, let's just pause. Give me 0, 0. So yeah, when 1 point didn't equal 0, 0, because we were trying to get to that origin, I knew we had a problem. It's all right though. We don't make mistakes, we don't learn. And I hope my mistakes here help you guys not to make the same. All right, so we shifted 1, 2, 3 to the right, and then 1 down, and this is going to go away because I'm going to color this guy in. So now, next step, we need to reflect in the y-axis. So your x comma y. Let's see. Hold on, give me just a second. Get my other page back. Be negative x comma y. So let's go down just a little so we can see, and I'll write out the answer at the end. Sorry, this is taking a little bit longer. So our p prime was 0, 2. Q prime was -1 and -0.5. And then our r prime was 0, 0. So negative x comma y. So can't make 0 is neither negative or positive, so it stays the same. And 2, so this is going to stay the same. This is going to stay the same. This is the only one that's going to move because we're scooting across. Q, -1, 1. So Q is the guy out here. And then -half. And then 0, 0. Can't change it. Doesn't change. So let's see. What color? All right, we'll do brown, and then we'll make this outside pink so it'll be easier to see. All right. 0, 2 still. 0, 0 still. +1, -half. Here. Because that was, let me just make sure. -1. Yeah. Making sure. So +1. All right. Now. I think I said the red wouldn't matter. So we've moved. We flipped. Now we're going to blow up or dilate. So how did... So let's look at our x up here is 0, 1, 2, 3, 4. I had it marked on the other one. Y is 1, 2, -1. Notice this guy staying the same. So we're not going to worry about him. But P and X go together, and R and Y. So P is 0 and 2. X is 0 and 4. Q is 1 and -half. 2 is 2 and -1. So look, this is double. So 2 and 4. 4 is double 2. 2 is double 1. And if you multiply half by double or 2, you get a whole. So it looks like our, so to dilate, it's x comma y, kx comma ky. So let me just show you guys. So if our P is 0, 2, and its corresponding side x is 0, 4, multiply 0 by 2 and you get 0, multiply y by 2 and you get 4. So let's just say k equals 2. Well, what's the other side? It's q, which was 1 and -half, and y, which was 2, -1. So if we multiply 1 by 2, we get 2. We multiply negative half by 2, we get 1. So our k is 2. All that for this. So how did we do it? We translated vector 3, negative 1, then reflected in the y-axis, then dilated. I always misspell it. Dilated. Scale factor 2. And I probably still didn't get it all on the screen. Alright, there's that. So, video got super long. It is what it is. Flipping over page 8. Give me just a moment.